systems.
Oh, it's us. Welcome. Hi, how are you? My name is Oleg. How are you doing? Are you having fun here at Devoxx? What about the other half people? Are you having fun? Yeah. Is this the first conference in a while or what? I feel like it's been ages without actual physical conferences, and I'm very, very happy to be here. So today we're going to talk about the integration tests. We're going to talk about a library called Testcontainers. And what I want this session to be, I want it to introduce you to Testcontainers and sort of inspire you how you can do complex things or interesting things with Testcontainers. And if I can do it here on stage, which I'm supposed to be able to do that because I just tried it before and everything worked. I have at least 2 witnesses, so if anything is botched, it's not me, it's just the accident. But I want you to inspire you to know that you can do pretty complex and interesting things with Testcontainers, and it's pretty easy to do so. So before we start, we are all developers, or most of us are developers. Some of us are managers, and one thing that I know I love is when I can start things from scratch. When I start new projects, when I create new apps, when I know that this time I'm going to make it right. I'm going to do everything correctly, and my code that I will write just now will never become legacy. Because, well, now I'm smarter than I was a year ago, and now it's going to be good. But then very, very often, one thing that I don't think about, well, now I think about because that is part of my actual job description, is tests. And apparently nobody likes to, very, very few people like to write tests. How many of you like tests? Okay, how many of you like to actually write and work on the tests? Much less. Interesting. Interesting. So it's not just you. Recently there was a survey by Retool, which is a company. They do sort of a low-code backend system where you can just drag and drop things. And they did a survey about the practices for developers, what people do spend time on, what they like, what their processes look like. And they separated this survey into 2 groups. The individual contributors who actually do day-to-day coding, 8-ish hours a day, except some time on meetings and Jira. And the top thing that engineers answered they would like to spend less time on was testing changes. They don't like to test. And what is very surprising is that the other group, which were the managing sort of the hands-on team leads, people who have more responsibility, which you would assume that they have more responsibility, and they're like, everyone should test all the time because that's how we write great software. The top answer, what they would like to spend less time on, also testing, which is very confusing. But it also, it makes me relate because I know that other people don't like to write tests just as well. So hopefully, maybe after this session, we will see a little bit easier time writing specifically integration tests. I work as a developer advocate for the company called Atomic Jar, which is a startup created by the maintainers of the Testcontainers Java library. And you can find me online, and I would absolutely be ecstatic to chat with you about anything, to be honest. So mostly software engineering, of course, but people say that I'm great about just in general life experience. I'm old, wise, sad, and boring. So yeah, hit me up, so to speak. Right. So Testcontainers. How many of you know Testcontainers? Very good. Approximately, I think a third. How many of you use Testcontainers sort of mostly daily? Very good. Fewer people. Very good. Do you do web applications? Mostly. Spring? How many of you do web applications but not Spring? Very few. Very good. This session will be based on the Spring application example. So that covers most of the audience, which is very, very good. Right. So Testcontainers, what it is, it's a Java library, or it's actually a collection of libraries in different languages. But what it does, it integrates with Docker on one side, and with your application frameworks and test frameworks on the other side, and provides you a programmatic API to control, instantiate, and manage the anything that runs in Docker containers. That could be your databases, your message brokers, your headless browsers, other services that you actually create yourself, and whatnot. So, and it's pretty great. What it does really well, it builds on the shoulders of giants, which is it works on top of Docker as a runtime. And this is pretty great. Why? Because first, Docker is almost universally everywhere. It covers the 3 major operating systems pretty well. Most of the technologies that you want to work with, as in like stock software, as I mentioned, databases, or your, I don't know, Elasticsearch or Kafka, have the Docker images that you can use to run that. And Docker allows you to do 2 things really well, right? It allows you to allow other people run your software without any friction. And to do all of that is it allows you to run other people's software in the same straightforward and seamless way. You don't need to install anything. You don't need to configure anything, mostly. You might, if you want, but you don't have to. And you have sort of a universal interface into running whatever you want, wherever you want. So we're going to use that particular aspect of Docker, running other people's software in a sort of isolated way on your machine or somewhere in your CI, and we're going to appropriate that for running your integration tests. And under the integration test umbrella, we're going to have the notion of you have your application, and it could be a microservice, or it could be a larger application, but it usually has some service dependencies that it needs to do for proper work. For example, it might not work without a database, or it might not properly work without other services that your peers develop within the team or within the company, or without Elasticsearch or something. So your application and one level of service dependencies will be the environment that we want to run for the integration tests. We don't want to run all of your microservices cluster or fleet, because it might be impossible to run locally. It might be very hard to run even in the proper cloud-based environment, because, well, it's much more complex than the immediate area around your application. So we're gonna limit that pretty well on the one level of service dependencies, and if those need additional dependencies, then the main answer will be to mock them on the service level with wire mock on something like this, and then run that in a container, but not go further away. The main reason for that is we don't want to fail the tests on our application if the errors or misconfiguration happens somewhere down the line. Because we want to fail the tests only when we are in control to fix that test. And when we work on this particular application, we want to fail the test only when this application is at fault. Right, so we're going to run in a Docker, and Docker is great. Right? It provides you with the process isolation, it provides you with access to file system and networks, it has the universal sort of API that you can pull images from registries and run them and expose them properly to your system. You can configure almost everything. It's also sometimes not particularly ideal for the very complex and dynamic situations like running integration tests, because you want to reinstantiate your dependencies all the time. You want to recreate the database. You want sometimes to put your, database into the situation which is like a corner case when everything breaks. You do want to test against that, but it's really unusual and maybe not so straightforward to just use the normal Docker API and Docker command line to recreate the environment again and again and again, specifically after you actually get into this picky situation. So how do you resolve that problem? Welcome, Testcontainers. Testcontainers Java was the first library out of the Testcontainers one. It was created 7 years ago, which means it's very mature. If you don't believe it because you are in the Java ecosystem and you think like 25 years is pretty young, then Docker is like 8 years old. So very soon after creating Docker, people came up with the idea of creating Testcontainers. It's an open source library. It's on GitHub. You can download it. You can use it. It doesn't use the command line. It integrates with Docker through the Docker Java API, so it actually sends the proper commands. And on the other hand, it integrates with normal frameworks in the Java ecosystem, so JUnit, Spring, Quarkus, Micronaut, all that. What it does a bunch of things besides just providing you the API. It tries to give you a good developer experience, so it determines the Docker environment automatically for you. It does a bunch of checks to verify that it actually has the basic capabilities to run things in that Docker environment. It does care very, very much about the cleanup because, well, you want your tests to be repeatable. So that means that you want when you run them and they successfully pass or fail or crash or happens whatever, you want the environment to be cleaned up, and Testcontainers takes care of that pretty efficiently. And also, just besides that, Testcontainers tries to alleviate a number of sort of, not mistakes, but a number of things that might be not ideal for the integration tests. So if there are any ports exposed from the containers, Testcontainers randomizes that ports, so to avoid clashes. It tries to be very flexible with how you initialize data and how you configure everything. It tries to allow you the opportunity to parallelize the tests efficiently. So we try to go an extra mile, and we try to sort of give a good experience, even if you don't really worry at any particular moment about the good quality of your tests. Testcontainers has you back, at least with some regards. So, as I said, it started with Testcontainers Java. Now there is Testcontainers libraries in almost all languages. So there is Testcontainers Go, Testcontainers Node for JavaScript and TypeScript developers. There's Testcontainers Rust, which is very exciting. I think there is a Testcontainers.net. I know somebody is trying to hack in their spare time on Testcontainers PHP. So the thing here is, the approach is generic. And the community, all those kind of forks, different program languages, implementations, they all come from the community. It's not us saying oh, you have to do this way. But it just people see the benefits and people create those implementations in their languages. And just recently, for example, the technology radar by ThoughtWorks firmly put Testcontainers into the adopt category, which is fairly great. And they said all nice things about that, how it could be your default solution for creating programmatic environments for the integration tests, which is pretty cool. Right, so Testcontainers is pretty great. Those are the basics. I want to give you a sort of an example, a sample, a taste of what it feels to create those dynamic environments for a test using Testcontainers. So we're going to go and show and look at some code. It's a Spring application, and obviously it's not IDE specific. I'm going to use IntelliJ because that's what I use best. But you can use whichever one you want because it's just a Java library. And we're going to look at the Spring application, and this is the business logic of our Spring application. It's a Spring application that works and talks about the ratings for the sessions at the conference. So we'll have the ratings controller, and it's going to talk to two repositories about the talks and about the actual ratings. And one of them will store data in the database. We're going to use Postgres because, well, why not? And the ratings repository, we're going to save the data in Redis because, of course, you need the key value store for numbers. And two components of our application, the ratings controller and ratings listener, are going to communicate through Kafka because that's how you build enterprise-grade software. It might be an overkill for this particular sample application. I mean, maybe two classes can just pass variables to each other, right, like arguments. But it does one thing very, very great. It requires a sort of a diverse and fairly complex environment to run, right? It needs a database, it needs Kafka, it needs Redis, and we're going to do that. So let's look at the application. Let's look at the application. Right, so this is our workshop here. This is our application. You can see that this is the normal Spring application. I cannot even run this because I don't have any environment set up, right? I don't have my database, so the application will not run. But you can see that it's exactly as I said. So we have the ratings controller that binds that ratings, and it uses Kafka to store, to like send messages, and it uses the ratings repository, which uses the Redis thing, and it uses the Devoxx repository with JDBC template. The exact technology of how you access database or Redis or other any service dependency is not particularly important. It's just to run this application or run tests against this application, I do need that database or I do need that Kafka. Luckily for us, we don't need to write the tests ourselves, right? So I have a test suite prepared here. It's a typical Spring Boot test. So it has a diverse kind of sort of tests here, whether the context loads and where the database has a talk by a given ID. We do hit the actuator health endpoint and wait it to return 200. And those tests are written using the Rest Assured library, which is a very good Fluent API library for creating programmatically HTTP requests. So we check whether this stuff is healthy. We do actually use the API, and we post the ratings to that controller that we saw before. And then we wait for the response, and then we wait for the ratings to propagate through our Kafka back to our application. And then on the ratings endpoint with the get, we wait, and when then we verify that the ratings that we just saved are actually there. So here we also use the Rest Assured for doing HTTP, and we also use the library called awaitility for any async waiting that happens. Even if you don't take anything away from this session about test containers, those two are really, really great. So if you're not using them, you're missing out, and you should maybe look at them. So awaitility one, for example, we use in test containers, inside test containers very extensively for various events that we need to wait for. So when we start the container, we don't want to give you control back until the container is started, for example, or a certain condition, like you run a database in a container. You don't just want the container to start. You want the database to be ready to accept queries, right? So we need to wait for a bunch of stuff, and then we use the awaitility for the organizing the API there, and it works beautifully. Right, so what we do here, we set the queries, and we wait, and then we do more tests, and then we expect the results propagate back, and we even just test for negative scenarios where a certain session is not found, which is great, because, good. Right, so I can run those tests, and they, of course, who thinks they will pass? Don't look there. Don't spoil it for yourself. Who thinks they will fail? That's unfair. Yeah, they will fail. Of course they will fail. There are no environment, right? There is no database. There is no Kafka. It cannot possibly actually run and do all those complex things. So if you look at the context loads, the most basic test, it does what it does. It checks whether our Spring application can wire things together, and then it actually talks to the database. And it cannot, because it cannot start the application, because there is no database. Somewhere here it should say no database. Failed the driver. Anyway, no database. Right, so now what we're going to do next, we're going to do the basic minimal necessary environment to make those tests pass in a true test-driven development fashion. How do we do this? We're going to go into this abstract class. So we extend this abstract integration test class. And it's very simple. Why it uses the extension here is just to have the code more suitable for the conference, because smaller classes. What it does currently, it says that it's a Spring Boot test, and we want to run our Spring Boot application on a random port, because what happens if we want to run 2? And here, so what we do, we inject this local port back into our application, so we know where to query it with Rest Assured. And we create this Rest Assured basic configuration, the specification for request, that just says, like, we're going to hit the local host, and we're going to send JSON, right? We're going to expect JSON back. So the basic boilerplate for the tests. So here's we're going to create our environment. And here is your intro to test containers. The most basic and most useful API for within Testcontainers Java is generic container. Generic container, and we're going to do it as static field, and we're going to start with Redis, because why not, right? And what we can say a new generic container, and what we need to provide the Docker image name, right? We want to have the image name for what container we want to run, and that would be Redis, say 6, and some version of that. So a recent EP of IDEA added the contents assist for Docker image names within the Testcontainers libraries. So now I can just do this, which is pretty spectacular, right? Oh, I can also do this. Check this out. And it goes to Docker Hub to find the image for me. How amazing is that? IDEA is pretty great. Right, so now this is an abstraction. This is our object that represents a container that is going to run Redis. We need to do three things. We need to configure this container, this image, to run properly and expose Redis from within to our host application on our machine. We do that using what do? We press dot. As a developer, I don't know how to run Redis, but I do know how to use my IDE. I type dot, and then with this smart face, I'm just sitting there picking what configuration I need. Sorry about this. So what I need to do, I need to expose the ports. I know that I will hit Redis with queries through the network, so I need to expose the port, and I know that internally Redis uses 3679, and this configuration will be similar to what you get when you do Docker run -p and publish the ports like that, right? So we're going to expose the port 6379 from within the container, and it's going to be exposed to a map to some high-level port, high-value port on our host machine, because we want to avoid the crashes, right? Because if we want to have two Redises like that, now if it will be the fixed port mapping, I will not be able to create this scenario, because it doesn't work. It will collapse on the collision of the ports on my host machine. So we do that mapping for you. Now, so we do have the configuration. Now we need two things. We need the lifecycle control. We need to start this container, because currently we just defined it. And second, we need our application to know where the Redis is, because, well, otherwise it will not know where to find Redis. And if it will not find Redis, it will still fail with the Redis thing, with not found something thing. So we're going to do that. Lifecycle, there is a bunch of things how you can manage that. For example, you can just call the start to stop methods on your container definition, which is really, really great, because, again, your IDE knows what you can do with those abstractions, and it helps you every step of the way. I'm not going to do it here. I'm going to do it within the thing that is called the dynamic property source thing. So there is an annotation in the Spring framework, and there are similar ways to do that in other application frameworks. But what we can do the public static void method here, say setup things, and we give it the dynamic property registry, which is the sort of the registry for the configuration for our Spring application that will take precedence over any application configuration that we had previously. So this is where our tests can configure our Spring application with the test-specific config. What I can do here, I can do, say, registry. Add the property, and I know that this is the Spring Redis port host, right? We need to do host. How do we determine the host? Where do we run the Redis? Did someone say localhost? Yes. No. 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 First, localhost is not defined in all contexts, right? Because you can run Docker in Docker, or you can run, maybe your Docker is not even running on localhost. What you do, you ask your Redis, where they run, because you have that power. So you ask the host from Redis, because Redis, this generic container, now knows everything there is to know about your Redis. And you do the same with the port, right? We don't know the port, so we just say get the first mapped port, or get the mapped port for the port 6379 outside. And this is the config. Now it's fully dynamic for our test. We should not forget to start our Redis, so we're going to do the startables, deep start Redis, join. This is sort of a shorthand for starting, and there are going to be more services, so I just want to go ahead of time and just say, I can do many things here. So we're going to do Kafka here as well in a second, right? So we're going to start this, and now this is all that we need to spin up a Redis. And after our test, that Redis will be cleaned up. It's going to poof, there was no Redis before, which is absolutely ideal because I can run now this test again and again and again, and it's going to run locally with any Docker environment that Testcontainers will find, and it will run on my machine, and I will commit this test, and it will run the same way on any other people's machines, like my colleagues. It will run as a normal unit test within this, or say integration test if you bind to a different phase in your build tool system. It will run the same way in your CI. It will run the same way anywhere. And the best thing is, if this test is a part of your normal testing phase that runs on every sneeze, on every commit, on every action, there is no way somebody can commit and push code without running this test, which is excellent, because it means that the test will work with actual proper Redis and check actual proper stuff, which is very, very good. Right, so we did Redis. It's also a little bit maybe boring to recreate all the abstractions and configuration like this from zero, from scratch. So what Testcontainers offers you is a great ecosystem of modules which allow you to do cool things. So we can say, I want my Kafka container, right? And this is the class that comes from a library, Testcontainers Kafka module, and somebody who knows how to run Kafka created that. How many of you know how to run Kafka in a Docker container? Honestly? Yeah, not many. I saw 2 hands, which is more than I usually see. So well done, Krakow. Right, and it's not easy, right? You need a bunch of configuration. You need to figure out what to do with the zookeeper. You need to know how to expose the configuration URLs for the configuration. You need to do some random commands, because sometimes, I'm not exactly sure why this is necessary, but this is necessary. Oh, I know why this is necessary. Because we expose on a random high-level port, and then we need to reconfigure Kafka to advertise on actually that port, because that's how external services can come into it. So we need to reconfigure that. So it's not something that you want to do when you just want to run tests of your application that uses Kafka, which is great, because with Testcontainers, what you have to do, you just say, give me my Kafka. New Kafka container, and you just say Docker image name, and you do the same Docker image name for whatever the container you want. I want the Confluent Inc. CP Kafka. What? Kafka? Is it the correct one? Yeah, CP Kafka. 546. This one I remember. Right, and here we don't even need any configuration, because our abstraction of the Kafka container takes all that how do you call that? All that work away from us, right? It exposes just the things that you just run. So we're going to start this. We need to start Kafka, and we need to configure Kafka, of course, for our application. Let it be static as well, because it's all static things, right? And I'm going to do Kafka, and I need the Bootstrap servers, right? So see how cool is this? Get. I don't even need to type anything. My IDE helps me, right? Which is great. It's not the Testcontainers benefit, it's just the combination. But the tooling is there for you. So we just do Kafka, and here we do Bootstrap servers. Right, so now we have Kafka and Redis, and if you are interested in that, right? So there are a number of modules for almost anything that your soul might want. The almost all popular databases, Cassandra, Cockroach, Couchbase, Maria, MySQL, Microsoft SQL Server, MongoDB, Postgres. There are modules for other things like Elasticsearch or Kubernetes or local stack if you work with AWS, or mock server, or you get the point. A bunch of those. And if you don't have a module here, you can roll it on your own with the generic container. Look, Kafka is one of the complex ones, right? But it's 100 lines of code. So if you actually know how to run Kafka, probably this is not that hard to write. So if you work with a certain technology and you want a test container for that, You can just create the module, whether in-house or publish it as an open source implementation, which would be great because other people can reuse that. So, and you can do even more complex things because it's all dynamic, right? There is no YAML here. There is no static configuration. You can just do what you do best is program whatever you want. We have 20 minutes, so we're going to speed up. So I'm going to show you the JDBC integration, right? Because we can do things on the fly, what we can do here, we can create the databases on the fly by just substituting the JDBC URL. So I'm going to say, I'm going to configure my test with a property, with a Spring data source URL. And usually you do JDBC and then type the actual, like localhost something where your database is. I'm going to instrument that with a TC prefix for test containers. And when Spring is going to go and look for the driver for my JDBC URL value, it's going to go and see like who knows how to handle JDBC TC. And the test containers driver will be like, me, pick me. And then what the driver will do, it will take the string that you have next here. So we're going to go PostgreSQL, and they say 14 Alpine. And take that image name and create a Docker container for you and start it and configure Spring to use that application, that database. So this is the simplest thing how you can create the database. You can also, of course, like create it manually here with, say, Postgres, right? You would do it normally. But you can also do, and this is the simplest thing. If you just need a database, you just need to fix one property. And it will do the normal thing. It will clean up. It will run with the actual proper database. And this is all, I think, all we need to make our test suite pass, right? How exciting. Do you think it will pass now? Why not? Did I forget something? Oh, shoot. Stop it. Yes, Alpine. See, this is the worst, right? Let's try it again. Can we run around again? Now it should work. Oof. The typos. This is why I don't like YAML, because it's a string. Right. Now what you can see here in my log, the cool things. So first, my test containers library figured out that I'm connected to Docker and tells me that yes, I'm connected to the Docker and does the checks, that it's a modern Docker and that it has access to the network so it can control the life cycle of the containers and it can map files and it can copy files. It does a little checks there because if it doesn't, if it cannot do that, there is no way you can actually run the tests. So it just wants to fail early if you don't have enough HD space because there are other Docker images that take it all or anything like that. Then it downloads, pulls the images, and of course it will use the cached images after a while, so after it stopped pulling. So the next test, it will not pull the images, but it will just run those. And you can see it runs all of them, and they're all green. How fantastic is that? We created a complex environment with Postgres, Kafka, and Redis, and wired it back into our Spring application in. So this is line 30. This is line 47. In 17 lines of code. And of course, they kind of hide quite a bit of complexity, but for you as an application developer, that is pretty straightforward. So this literally just, you need the definitions. And then you can do any sort of cool things. So here, for example, right, what we have here is the application, and the database is initialized by Spring. So our application here, if I go into the application YAML, Spring initializes our database. Sometimes that might not be the thing that you want to do, because, well, first, you might not want to initialize it the same way for your production and test applications. So you don't have to do that. You have the full control over what you want to do. So here, let's do the Postgres manually. Static Postgres. Postgres. Right, and it's a new Postgres. And we'll do the same thing. What is this? Postgres 14 Alpine, right? And it's a Postgres container, so it also encapsulates all the logic there and the things. So now I can manage it manually. And what I can say, because I know that the Postgres container has means to initialize the database initially, right? I want to configure this container. entry point. Yes, initialization script. So if in this Docker image, and this works for almost all databases, MySQL and others as well, right? If I put something in the Docker entry point init folder, those scripts will be run when my container is starting. So I'm going to do exactly that, and I'm going to take my schema, which is here in my schema file. My schema file, look, it creates the table, and it inserts 2 talks in there. Testcontainers is amazing, very good, because this is exactly the ID that we use in our tests. And I'm going to configure my Postgres here to have that file put in that particular location. So what I do mountable file for class path resource, and I do the schema SQL, right? And then what do I need to do? I need to put it into the path, which is this thing, right? And it's a directory. Boom, done. Now, when my container is started, the file will be copied in there, and that will be the configuration for my database. And with other services, you can do the other things, right? If you have your Kubernetes cluster that needs some cluster definitions, some YAML files, you can copy them with the same mechanism. You can have them, and for the particular task, you can copy them in there if you need, right? So now we're going to start this. What we need to do, we need to start the Postgres, right? And we need to configure this, because now nothing takes care of the configuration. So we need 3 more lines. So Spring Data Source URL. Spring Data Source URL. How do we get it? Who knows how to get the URL? Postgres, get JDBC URL. Boom, done. Magnificent. And we need username and password. Username, Postgres, get username. And the password is the same, right? Password. So now we do, again, the same thing again. Password, and this is get password, right? Now we do the same thing again. We manage the lifecycle of our container. We manage the configuration here with our with-copy file to container. We manage the lifecycle by starting it, and we manage the configuration. And we don't manage the stopping it, because Testcontainers take care of that. So now the Spring doesn't initialize our thing, but our test is supposed to run. So let's do this. Let's run this one test that actually talks to the database and see whether it actually succeeds without using the Spring to initialize our database. How amazing is that? Who thinks it will work? Who thinks it will fail? That's a solid bet. I assume that it might fail all the time. But I think in this case, it's supposed to work like a charm. There was an exception, was it? No? What? It's supposed to. Yeah, what? Found no schema public, but schema history table, baseline? What are we doing here? This is the flyway thing. It's not supposed to even be here. Right? No flyway, so no schema things, whatever. Give me. It's supposed to work. Right, but the next step, I'm going to show you how to initialize it with flyway, which, if this doesn't work, we're going to go straight to that thing. Just knowing that we can configure our containers using the Fluent API like this. And you have everything under control. You can specify the particular things for the technology that you're running in, or dependencies between the things, or specify the resource mappings, or the commands, or the environment properties, or anything that you want to do with the container. OK, so now you are green. So now it's green. Now there is no flyway. Let's do the flyway now. So this also might be not the best thing, because you might want to have this in the same way as you initialize your production database. So for example, with database migrations. So let's do this. Let's copy this thing, and let's remove this, and let's put it into a migration file. Right? So a migration file, let's add the flyway back. Now, don't forget to re-import the Maven. Now we just don't even initialize our application database within the tests. We know nothing about that. But we can still run this test. And now, when the Spring application will start, it will find flyway in the class path. It will find the migrations where flyway expects to find the migrations. And it will run them against our database and create the schema that we want. You can also use for your migration library, what you can use whatever the separation between the production migrations and test migrations for anything if you want, and then it will work pretty beautifully. You can see that it migrated the schema public to a certain thing, and then the test is green, which is great. What else can you do? The life cycle, right? Managing the life cycle can be tricky because sometimes you want the full isolation for every test is getting the new instances of the containers. Sometimes you want to kind of sort of clump the tests together to work against a single instance of a database or, I don't know, Kafka, because you don't want to restart those containers all the time. And you can do this either with the manual control, or there is a JUnit integration where you just put annotations on top of your fields, and the JUnit test lifecycle will be tied to your Testcontainers lifecycle. Or if you really know what you're doing, you can even just say, I want to reuse my containers, and I want to reuse them across multiple tests. So if you specify the reuse, then those containers will outlive the duration of the tests. So if you run multiple tests, right? So let me just do all of them. Wait, Postgres as well. All of them with reuse true. This is the property, and it's experimental because we don't know actually when somebody needs to clean up those containers. So if you enable that, that's on you. And then you don't just enable it here, but you also enable it in the configuration file for the environment, because we don't want an ECI to just run and leave the containers hanging there if you run on a powerful machine. So you need a property in the environment that says like, yeah, I'm okay with the reuse. And you need this configuration on the API level because maybe not all of the containers supports the reuse. But if we do this and then we run our tests, then what happens is that, wait, let me do Docker PS quickly. No containers, right? Docker stats. Now the containers will start, and they're starting there, and they're running as normally Docker containers would. But then, well, you saw that before there were no containers. And I ran tests before, so you know that the containers were cleaned up, because otherwise the test will not. So they will create it and cleaned up. And now with reuse, my containers will be still there. The tests pass, look how cool it is, and I can run it again. And it will not start the containers again, but it will find, and like it does a cool thing of hashing the container definition. So if you change the config, it will start again. But then if we just rerun the tests, it says like, you know what? You said there was reuse, and here's my Postgres that I already had running, so I'm going to just use that. How cool is that? This is pretty cool. Right, what else can we do? Oh, the containers are started on randomly high value ports, right? So sometimes you might want to be like, oh, I would like to connect to that database from my IDE. Because why? Because you want to look at something from in there. And it's kind of like sometimes awkward to do when everything is so dynamic. What you can do very simple things. Because we know that it runs on the high port, what we can do, we can create a proxy that we will manually run. And that proxy will run on the static port because we want to fix it in our IDE. But then if the proxy is enabled, it will proxy to that dynamic configuration. Right? And in the interest of saving a little bit of time, I'm going to do what you're going to do, and I'm going to copy this snippet there. Because, well, nobody else needs to do that. Right? So we're going to create a proxy. And this TCP proxy comes from a library, and Java ecosystem is so great that there is a library from anything. But what we just do here, let me just take this. What we do, we just say Postgres. We just say, take the Postgres and map local port 5900 to the config where our database is running. So let me show you how it works. So we're going to work on this test. And don't do this at home, but this is the simplest thing to stop the test. Instead, like I could have used the breakpoint, but this is much cooler, right? Don't do that at home. So now the test will pause because the scanner will try to read something from standard in, and it will not find anything, so it will wait there. So why I'm doing this? Because I want you to show that my proxy will be running. So we configure that to run on 5900. So what I can do now, here, wait, where's the view? Exit. Wait, this is interesting. There is, oh, the database thing. So here, I can specify my data source configuration, and you can see here that I'm using, because I'm using the proxy, I know that it will be on the fixed port. So I can just use that, and if I test my connection, it's supposed to work now, succeeded, very good. So let me connect to this, connect, test, public, my schema, 2 tables. So there are my talks. You can see that there are my talks actually in the database, and our flyaway schema, which is exactly what we run. And you can do this with all technologies, because it all runs within the thing. And then, yeah, you just proxy and fix the configuration for your environment like that, because you know that in development, this is good. Right? This is perfect. Right? Perfect. What else can we do? Even more complex. What is more complex than proxying stuff to our... Let's do a little bit, if you're feeling particularly fancy about certain tests. With test containers, what you can easily do, you can sprinkle some chaos engineering practices into your test environment. So what I can do I will use a module called, well, let me stop this for a second, because I don't need that test running anymore. You can use the library called ToxiProxy, which will proxy to certain containers, and then it can introduce all kinds of network side effects, for example, latency or jitters, or cut the connections down, and you can have your tests programmatically create those complex environments and complex network topologies. So this is the example of that. So we're going to say that we want a Docker network, and this is the network, new network, and we're going to say, like, say my Redis. I'm not sure if this is work with reuse. Let's go. With network, with network aliases, let's call this Redis. Let's do the appearance presentation mode. Thank you for reminding me about that. Mostly Brian, I'm looking at you. Right, so we do Redis, and we put it on the thing, and we can do the ToxiProxy thing. ToxiProxy container, ToxiProxy container, new ToxiProxy container. You can see how the test writes itself. I know that it's Shopify, ToxiProxy. I think ToxiProxy. No, it's this thing, right? Slash, and here we do 2, what? No? 0, 1, 0? Right, so we create the ToxiProxy. I hope this works. Where's my content assist? Shopify. ToxiProxy. OK, 201. I tried it before. It's supposed to work. Right, so we do that. We start it. It's very important to start the ToxiProxy container, because otherwise the test failed miserably. And then we're going to say, ToxiProxy, get me the proxy for Redis, for the port 6379. And that is our new Redis, right? And then we just use that for our configuration. Get container IP address, yes. Redis 1, get proxy port. Now our Spring application will go into this proxy. And what we can do next, we can say, Redis 1, get Toxics, and say the latency, slow. And we say the direction, we want the downstreams being slow, and we say the latency is like 500 seconds. And we can do more things, like, for example, set jitters, or say this is like a second long jitter. So now our Redis will be fairly slow, because we're gonna introduce the latency there. So let's pick the test that works with Redis and see whether this test actually became healthy needs Redis. So whether this test became slower, which is kind of cool. We're gonna wait for it. What, sorry? Yeah, we created the network, and we put box. ToxiProxy needs to go on the network, right? With network. Network. Yes, thank you. That is great. So now it was very fast. Let's see if it works now with network. Run again. No, it was supposed to fail. I think something doesn't work here. Now it's supposed to be slow because we introduced the network jitters and the latency. The moment of truth. Right, let's assume it's slow because it's out of time. Let me just show you a couple more slides. Right, we're going to come back to that to figure it out, but it's supposed to be slow. Right, so what I wanted to show, that you can do even more. You can create more complex topologies if you have a bunch of services that depend on each other. You can create custom startup and waiting strategies if you want to configure when exactly your container is started. For example, if there is a service that responds to health checks or anything like that, you can create images on the fly through Docker files or through API. Of course, you can use and file the logs and files and copy files back and forth. You can specify the limits for CPU and memory. You don't need to write a line of YAML to configure this. Because why? Because you have libraries in your favorite programming language that support you every step of the way. So your IDE is there. You can run this anywhere where there is a decently compatible Docker environment, which is almost universally everywhere, right? So, and this is, I think, like a nice thing. You don't want to have a hard problem and create a hard solution for that, a complex solution. That is not a win. And also, easy problems with easy solutions are also not a win because they were easy, already, right? So, but when you take something complex and hard as a problem, like creating those dynamic environments, and you replace that with the reasonably simple solution that you understand how it works and you can configure, you have the tooling that supports you, then I think that is a pretty big win. And I think Testcontainers hits that niche very, very well. Right, yeah. And if you don't have Docker, worry not. You don't have to actually work with any particular Docker implementation. As long as it's compatible, you can do that. We run a bunch of experiments, and we run the Testcontainers Java test suite on Windows and Mac OS on various Docker implementations. And we are working with the Podman team to figure out what broke, because it was unclear what broke there. But if anything exposes Docker, remote Docker, local Docker, Docker in your Minikube Kubernetes cluster, Docker machine, which is an older way to run Docker, Docker desktop, all of those work great. And we at Atomic Jar are building sort of a cloud backend for running your test containers-based tests. So your tests run locally, but the containers are spin up in the cloud, and it works seamlessly. In fact, this is an M1 machine, and I'm not sure if it runs the Kafka images or not, but I'm running the Testcontainers cloud there, and it connected to some sort of a cluster with the 10 milliseconds away from me, which is a great testament to network here. And you didn't even notice that I'm not running Docker locally. How cool is that? Pretty spectacular. So if you're super eager to use that, unfortunately, you currently cannot because it's in the private beta. But you can go on the URL and fill the form, and some people, not me, but some other people, will figure out and prioritize access to things. But yeah, so we are building that, which is kind of cool. Right, and if you want, the application, the sample application that we looked at is in the Testcontainers repository under the workshop. The implementation of the Java library is there. Testcontainers.org is the documentation and everything. And you can check it out. It all works pretty great. Thank you for coming. And I hope you will have the great rest of the conference. Thank you.